Um, so the title of this presentation is probably very vague and means absolutely nothing to you all, which is okay. It's, uh, it's a specific infrastructure that we've set up in our own company, but it's not the implementation which I really want to share. Of course, I'll show you through the implementation, but it's more what went behind it and the kind of methodologies that we kind of pieced together to get this thing up and running. And that, I think, will be more relevant to most of you, especially because I'm coming from a more desktop application kind of background, and I see a lot of you are like web guys. So the exact technology may not be relevant to you, but let's hope the methodologies are. So just an overview of what I'm going to go over. Since the name of the company is also probably very vague and means nothing to you, I'll go over that. I'm going to go over some typical problems that we've had with test automation. Again, this is it's going to be about our domain, but then those things can be applied other places. And then I'll step through the infrastructure that we came up with to solve this problem. So first things first, I work for Muvee Technologies. I'm actually not a generic geek, at least that's not what it says on my card. I'm just a software engineer in test. And what we do is basically create software and solutions for creating, automatically producing and creating video, music videos or home videos, instant home videos for end consumers. We were founded in 2001 with 8 people, and now we're slowly approaching 100. So we've obviously stayed small. It's a decision, and which also means that we have to be very efficient in our usage of resources. And yeah, it's okay if you hadn't heard of us. It's good. And we're based in Singapore. Where Singapore, in case some of you don't know, it's that big black dot at the bottom of the map. The dot is covering where Singapore is, so I'll zoom in, and it's still covering it, and it's still covering it. So it's generally somewhere around there underneath Malaysia. But more importantly, Singapore, there's a common myth that you can't chew gum there. That's not true. You can chew gum there, and it's all good. So just a deeper look into what we do. We've created patented technologies underlying, core technologies that basically deal with the art of video editing. So if you speak to any conventional video editor, they'll talk about how to cut a video properly, how to sync it to the music, things like that. So we've transformed those into algorithms that are patented to be used for software and solutions that we create and provide those services to the user. So you don't need to be a video editor, or you don't need to have experience in using some like high-end software that people use for video editing. So this technology is then ported onto actual products that we create and sell. And it's basically targeted at very many platforms, because the whole point is to get everyone to use it. So we've got products on the PC, we've got them embedded into digital cameras or mobile phones, camcorders, and the like. We made something for the Windows Media Center, which apparently no one uses, but it's a Media Center implementation by Microsoft. We've got stuff on photo kiosks, and we're venturing into the World Wide Web now. So you guys are far ahead in terms of web technologies. I won't go there. And at the same time, we've got an SDK that we provide to other customers. So the same layer of technology is shared with other people, and they leverage on the same APIs and try to create their version of the application for their suites of applications or whatnot. All right, so with a picture, because pictures are nice. This is our basic technology infrastructure. Most of you probably have similar kind of setups where you have support code right at the bottom, which may interact with third-party tools or third-party SDKs and so on. And in the middle, you have your controller layers, which could be in the form of an SDK, or you form specific controllers for specific applications. And then right at the top, you have your GUI code, which could be in whatever language. So as you can see, underneath, we've got lots of C++, but outside, the user-facing aspect can be in whatever, we've used C++, C#. We're using Java and HTML for our web front, so it could be whatever. So the problem comes when you've got a kind of messy, but it's divided up nicely, but it can be messy. And you want to test different configurations of these modules. So we've got a whole bunch of things that are going around and creating final products out of these little blocks and pieces of code. So one path is this. This creates our media center application. Then you can have another path which creates our desktop application. Then you can have something that completely eliminates the controller and GUI, but still creates a product that we sell, which are plugins to other applications. So this becomes a big problem because you can't, if you apply any traditional GUI-based testing methods or create test applications to test your code, they can't be used for all of these final products because they may be GUI influenced or whatnot. So it becomes a bit of an annoyance to test these. And there's a few things that you could do, or at least that we've tried. We could have capture tools, which is capture and record your GUI interaction and then execute that code to test your application. You could script the automation by putting hooks into your UI. Different technologies have different methods. Of course, you can write unit tests and scatter them all over the place. The problem comes obviously when you've got a very deep infrastructure. So you've got lots of unit tests everywhere, and they're all running around. Or you could write little sample applications that emulate your final product, and you test through there to make it more conducive to automation. So the two typical ways are obviously testing from the GUI and testing from the backend. From the GUI, the problems that we've had are that the representation of the GUI is not necessarily, and most often not conducive to automation. You're not creating the UI so that people can automate the testing on it. You're creating it so that it's usable. And the two things don't necessarily go hand in hand. The second big problem that we've always had is that changes in the UI mess around with your testing cycle. And that's really not a fair way to do it because you introduce new elements in your UI or you change a skin, you put new text in it, you localize it. That really doesn't have much to do with the underlying behavior or functionality of the application. Yes, it has to do with UI testing, but it doesn't have to do with your whole application. So that can skew how you approach automation. For the typical example is that you want to create a scripted suite to test your app, and you're waiting and waiting, the UI isn't ready, someone decided to just shift everything, and then suddenly your scripts go obsolete. You localize it, your scripts need to be, they need localized data and whatnot. And that really slows down your testing process. You don't want to be sitting and debugging test scripts. You don't want to be sitting like, is the problem because my automation tool is slow, or is it executing it in a funny way, and is that why it's crashing? Or is the system not responding because I've got overhead because of my testing tool? I've actually had problems with a testing tool where it was adding so much of an overhead to the system that would slow my application down because of that. And that skewed my performance tests. It goes all the way. And again, because you're going through the UI, if you want to test deeper functionality and how it would react because of UI interaction, it's not the most efficient way to do it. Also, gathering data can be a bit hard when you're going through a usable user interface. So I'm going to do a quick demo first, which is basically going to set up the problem domain that we have. So it's kind of like a shameless demo of my app too, but that might help you understand what's going on. Also, be warned, I'm using VMware on the Mac, and it's kind of beta-y, so I apologize if it crashes. But then again, cutting edge, right? So. All right, so this is the main UI of one of our applications. I hope you guys have kind of figured out what we do, which is take media, pictures, video, music, and mash them up into a professional-looking video that people can actually share and use. So typical scenario, I'm just going to drag in a whole bunch of pictures. Right now, when I'm importing pictures, there's a lot of stuff going on, but obviously what you just see is a single function, add picture. And from the UI, all I'd be able to do is leverage add picture. But underneath it does, whatever, media checking, this, that. I don't have access to those things from this point of view. I'm going to throw in some video, so the UI can react. This, of course, would really mess up your point-and-click recording system. And then I could have errors here, which I would have to catch and figure out using UI elements, which is a bit of a pain. So like right now, I just added a bad media file. It's going to pop up a dialog, and then that's not really the most conducive way to find out what went wrong. And then I'm going to, so this is the basic workflow, and a user would basically just go and click make. And now it's going to do all the stuff that I talked about, the algorithms that we have. Now, this is invisible, and I don't know what went on there, but my UI just shows me, okay, it's done, and I have a production. So what happened, I'm not going to show you all of it. So you kind of get the feeling it makes a production out of it. A lot of stuff happened underneath, and I don't know how it happened from the UI perspective. Now, it gets funkier when I change very small parameters. I just removed a music file, changed a music file, and just selected something called a style here. So basically, 3 actions. And I redo my same make sequence. Again, it did something under the table. I don't know what's going on. And now I have a completely different output, which is affected by a lot of different parameters. Those parameters I had no access to again. So I don't know how to verify this because so many things happened underneath, and I only did 3 things to change it. Well, we haven't had much video and audio, so why don't we watch this for like 20 seconds.
Wrapped in the warmth of you, loving every breath of you. Still my heart.
All right, I'll cut it short here. So that's just like a basic setup of what my problem is, because I've got complex inputs into the system. You know, media is not a simple data type. It's not just text and whatnot. Of course, there are textual inputs and numerical inputs that you can gauge a bit better. But I've got weird things like pictures, video, bad video, music that has different patterns, you know, like beats and tempo. These aren't things that I can just test or verify. And then when the output comes, it's all even more complex because it's an amalgamation of complex inputs creating an even more complex output. So it's hard to just take these as basic things that you need to verify. I mean, just imagine, this is a video production of different things. How do I say that it's good, that there were no bugs? Bugs can be in very different forms. They can be bad artistic productions. That's a really weird thing to gauge. Yes, pass or fail, how? I don't know. It's goodish or badish, I don't know. So yeah, that's basically my problem here. Getting back to the slide thing. The other option, not going through the UI, it's going one step back, taking the controller point of view. Of course, you can have different controllers and you can instrument them differently to test them from that point of view. The problem there comes when you have, as I showed you, a very vertical integration of modules that the context of a real world use case can be lost. I can apply unit tests, I can create test applications that test certain parts of the code, but when the information flow isn't there, when they don't interact with each other, the actual problems that occur in the real world will not be they won't be found using these methods. That's not to say that unit tests aren't good or integration level tests using unit tests aren't good, but it doesn't solve the problem when you're trying to do it fast and smart. You can keep them running and you'll get good metrics out of whether your code level testing is good or your unit tests are passing, your developers are being sane about it. But when you want to do a release type of testing, it's not so efficient. Secondly, when you get the controller aspect of an SDK type API infrastructure, which you're trying to test using certain methods, you tend to bias it, or at least we do. So basically the developer of that interface will bias according to his view of what the correct implementation or correct usage is, which is not necessarily the real case in the real world. All the correct paths may pass, but suddenly an injection with a weird thing is going to cause a problem, and you didn't account for that, and you have no way of finding that out based on these unit level tests. And the biggest problem that I find with unit tests or lower level tests is that they're not shareable. I can't just take some unit tests and give it to my QA guys and say, here, run these, because they're like, this means nothing to me. This is your unit level testing. It should pass anyway, right? So if you can't share, you can't make efficient use of these tools that you've created or tests that you've written. In theory, if you have a developer who's written some unit level tests, those same tests should be reusable in a release type of context or a smoke test or a regression test. These elements should be reusable across the board. It's just that people have different perspectives when they're testing. A developer is testing just to make sure his code is okay. A release engineer is testing so he doesn't get shot when he releases something. Someone just testing from a daily build perspective is making sure every day's builds are seen. So the perspectives are different, but what you're testing underneath is the same. It's just you're testing at different levels of the infrastructure. So yeah, that's a pain when you write all these things, but people can't share them and you can't reuse them. So just a kind of summary of the problems we've had. From testing from the GUI, I've got a lot of reds. I've got all reds. Point and click, not maintainable. Things change, you have to go back and modify your scripts, whatnot. They don't comprehensively test your code base because you can't see all your functionality, so you can't possibly say I'm testing all the functionality when you can't even see it. And the lifetime, again, lifetime is a problem. You don't want to go back to your test suite, your scripts and what, to redo it every time you have a .1 release. That's really ridiculous. Again, with hooks or programmatic scripting your GUI, same problems arise. You're going to be doing a lot of custom work, which isn't worth it. If you take a step back, okay, we see some greens here. Unit tests, yeah, of course they're maintainable. They'll be running forever as long as the code is there. Great. But if you take testing tools or test applications, again, if you add new functionality, you have to go back and add it into your test tool, write up how you would actually test it through an application perspective. Lifetime of unit tests, yeah, again, it's long. Testing tools, no. Comprehensiveness is a bit of a problem. It can be yes or no. It depends what you're trying to say is comprehensively tested. But if you try to look at the bigger picture, it's not necessarily going to be comprehensively testing all your scenarios. So that's a yes and no for me. And then, so because I'm coming from a smaller company and we've had the teething pains of like, okay, we need to automate, what are we going to do? So you always hear all these like, this is why automation is good. Why don't you buy this tool? Because it's going to be these things. And these are, great. But it depends how you look at it. If, again, going back to my favorite enemy, point and click capture, does it really save you on, on costs and speed? Because if you're going to sit and write those scripts, maintain them, take time to debug them, is it actually faster than doing it by hand? I don't know. Like sometimes it can be just more of a pain and slower. You have this perception that it's automated, so it's going to be obviously faster, but it's not always the case. Comprehensiveness, again, like it depends how it integrates through your whole infrastructure. If it's not covering everything, it's not comprehensive. It's only comprehensive for a certain point of, from a certain point of view. And then again, reliability and reusability, I went over those points. How long do they last? What's their lifetime? So it's not always, just a test automation can't always be a final solution in some form. Like you can't just pick something up and it's going to work for you. And this is the kind of problems that smaller teams often have because they choose the wrong tool and then they're stuck with it. And they're trying really hard to make it work for themselves and actually end up spending a lot more time than you needed to. So moving on, MuFAT is what we call this, Muvee Framework for Autonomous Testing. That's a long-winded and weird name just because, I had to choose it, so obviously it's weird. The disclaimer here is that it's only been in development for like 2 months. When this talk got accepted, it was nothing. There was no implementation. It was an idea. So yeah, it's a good idea, I think, but yeah, so the it's basically like a prototype that kind of works. So I will give you a demo, but yeah. All right, so the basic concept behind this framework is it's not a fundamentally new idea that just solves the problem. It's more of a mashup of simple ideas that people have tried or concepts that have been out there, but we're trying to apply it to automated testing here. Some aren't really automated testing methodologies, but they kind of mix up together for us really nicely. And if you guys can use it, wow, that's great. So okay, there's the first elemental key here is that we need to automatically generate as many unit test stubs as possible. So these are what we call building blocks of this whole infrastructure. This builds up to being able to create complex building blocks which take these smaller bricks and create larger tests. And if you think of it via the diagram I showed in the beginning of our infrastructure, if you start from the bottom up, you've got simple functionality adding up to a more complex functionality, adding up to whatever, and then finally ending up into the user interface, which is also basically an amalgamation of different levels of functionality mashed together. So if you can apply the same concept to test stubs, I know there was some talk about what stubs are and what mock objects are, but I'm just going to assume a stub is something which has an entry point, and that's my building block. So the same basic building blocks can be compiled together into more complex ones, and they still have the same interface, so that's the key for the building block. And then once we have these blocks, what we want to do is be able to model our systems at different levels using these blocks. Again, your functionality is being represented by not unit, but building block tests. And then we want to chain them together some way so that the information flow actually works out with these blocks. So they create real paths that may occur in the system or unreal paths or whatnot. And lastly, of course, logging and debugging is key because you want to figure out what happened. Everyone does logging. We've managed to do logging with point and capture kind of things, instrument our own logging. But the problem comes when your logging isn't meaningful or your messages aren't meaningful to the person who's going to be looking at this information. You may have some kind of log which says pass, fail, pass, fail, pass, fail all the way down. Right. Something fails. The developer who has to go and look into the problem, the pass and fail doesn't really help him much. It just tells him it fails. So what we want to try and do is get some deep information and not necessarily be visible to everyone. So depends on what perspective you're testing from. If you're again, the release engineer, all you want to see is, I want to see all greens. I want to see all passes. If you're not doing that, you want some more deep information. Even when a test passes, you may want to know why it passed, or wow, I'm surprised it passed. Let's see what happened here. So basically, some more abstraction in terms of what kind of messages you get and logging behavior you have. Right. So a building block. One of my colleagues is really fond of patterns and such, so he suggested we use a compound pattern, and it works out pretty nicely. You can't see, I guess you can't see those XML descriptions, but just take a look at the diagram first. Basically, everything derives from a test stub base for us, which is a simple block which has two functions, can execute and execute. So I asked the stub, can you execute? It says yes, okay, then I execute it. I don't know how it's going to do things inside it, but it's going to do something. So on the left-hand side, you have the configuration input for a stub for a unit level test. And on the right-hand side, you have the same configuration for a complex stub. The fun thing is that they actually look the same. So they've got the same interface. So again, they have the same interface for inputting data. What you input to that stub is another story. It could be simple, 1-0 parameters, or it could be pointers to another config, or pointers to other configs, which basically trigger other smaller tests. But the key here is that it's compound, so it could be as deep or as shallow as you wish. Right. So, all right, shameless name dropping because I want Guido's autograph somehow. If only. Anyway, so the automatic generation, this isn't something that you can just pick out of a box and use for yourself, because everyone writes code differently, different languages, so on and so forth. But we basically just parse our interface level interfaces of all our code modules, and take that and generate unit level tests for all those interfaces. And at the same time, what we do is we also pump out some templated, what kind of input is this test expecting? Because obviously, if I figured out what the interface is, I know what goes in. I may not know what kind of permutations I can pass to it, but I know what kind of types it needs. At the same time, what we kind of got as a free gift here is that because you're parsing your code regularly to create tests, you're also keeping track of what your code is looking like. So one of the fun things we got from here is that since I'm generating all these unit level tests, I also know which ones got generated. And at the same time, I know which ones are being executed. So when a unit test doesn't get executed, it can complain, hey, someone test me. So it's like a sanity test that I have all this testability, but are you testing it? Right, complex building blocks. Now, this can be absolutely anything and everything under the sun. You could just take a few unit tests and chain them together programmatically. So I call a unit test, a unit test, a unit test, and that becomes a larger level of functionality. And then the same block can be added to another block, which is maybe my final API. Of course, they don't have to use the same building block methodology. Inside a complex stub, you could put in whatever you want. You could actually code out how you would code out something in your final application. So that would be a closer representation to how your final app is using it. And at the same time, you could do absolutely irrelevant things inside a complex building block. You could do things like, a little complex stub which eats up processor cycles or hogs memory. Things to emulate your real environment, but within the same ecosystem. So you don't want another tool outside which is hogging up memory or clogging your network or whatever it is that you want to emulate. You can just stick it in as part of how you're testing the application and create these conditions at the same time. All right. Then chaining is the second factor here, which makes it useful for us. So we've come up with two kinds of chaining of building blocks that we could use. One is fixed paths. Fixed paths to us mean basically test cases or test paths that we know of, that we know should pass every day. Things like regression, of course. You want to be able to say that, okay, I run these paths and they work. At the same time, you could do some randomness in your fixed paths and try out like some different permutations. And as soon as something fails, you can add it back into your regression because okay, this failed. I'm either going to fix it or change the way I'm going to test it or change my test expectations. But the fact is that you have these paths created and you can just reuse them automatically. The next 2 points may not make much sense to you right now, but basically how we look at it is that the actual the data representation of a fixed path for us is also something that can be used as a bug reporting tool. So it's basically a means of communication between different people who are interacting with the quality of a software. I'll show you an example later. It might make more sense then, but it's basically a common language for a tester, a QA, release engineer, a developer of a high-level module or a support module to talk together because they're just passing paths to each other that this path failed, can you see what's going on? Okay, it's fine now, I fixed it, can you make sure it works? So you can verify, report, do all these things with the same kind of like language. Then the more fun starts when you start doing random testing. Atif and Andrew did a great talk on this because I was worried I wouldn't be able to explain it. But since they're academics, they obviously explained it much better than I could. So I'm quite pleased with that. But the point here is that monkey testing can actually be quite useful. You can go absolutely random with things which make no sense, and they can expose certain parts in your software which were never known. This works with our infrastructure because what we have is a simple interface which basically exposes the same two functions to the user of the test, which is, can I execute or should I? And if I can, then execute. So you can walk these random paths with very simple methods of finding out whether a test can run or not. You just check if it can run, and then you run it. Sometimes you run it if it can't run, and go nuts, basically. Right, the free gift I'll talk about now. So the sweet spot, it's a fun paper I read. It basically talks about machine learning in terms of finding out what kind of paths you can take in your software system. And these guys basically, they applied this to, I think it's an EA Sports FIFA game. So it's a soccer game. And what they did was they tried a lot of different ways of trying to score a goal. They constrained their test domain to basically, I think it was the D of the soccer field. So in that area, you can try to do whatever you can that is available through the software interaction with the game and see if you can reach your end goal, which is to score a goal. It sounds funny and sounds more like a gaming kind of theory, but I guess you could apply it to a lot of things. For us, what we think we can use it for is find a certain goal that you want to achieve in the software system, break it down into smaller models, and try and achieve that goal in whatever way you can. Once you find out that this certain path actually succeeds a lot more, it might actually turn out to be your most common use case. This may or may not be correct in many cases, but if something can be executed very easily and everything held constant, your software is more like a little bug-free, then you know that this is probably what people are gonna try and do with this because it seems to succeed most of the time. So and they can reach their end goal. So yeah, this is one of the fun uses of this. So this is probably a very typical state diagram of some kind of interface that you may have. I don't think you can read those things, but it basically says initialize, add picture, add music, add video. Again, may not mean anything to you, but it's just an example. But you can take it kind of back to the demo I gave before. This converts into this way of writing out these models that we've chosen. It's just an XML format. And it looks really complex and weird, but the main components here are things like paths, sequences, and sets. These are the main components of this state model. Everything at the end of the day contains a test case, a test stub, and the configuration you're going to feed it. You can just, basically, all of these models can be transformed into these structures, and these structures can be used to generate paths, basically. That's the key here. So if you look at this really weird and complex thing, you could actually carve it out and make a simple fixed path, which is just the basicest functionality I want to test. This model is saying, I can do this in this method. Can you find me a simple straight line through it, which will tell me that, OK, most of it works most of the time. At the same time, it can give you really random paths or let you permutate your state model in ways that aren't really easily creatable. Like you can't create all those different permutations of test cases by hand or by standard methods of generating test data. So if you have this model structured into something that's readable by the system, you can actually create these paths.
Looks like we're good.
Of course, you can make simple ones out of it, so you don't have to choose all the different things happening. And then you can just take random walks. So basically, this is a blank slate. All I know is that I need to initialize my system, and then I can do stuff. If I want to explore it, I can find out really invalid paths, which basically I'm going to say, OK, this is invalid. I don't even want to let someone do this. But you also want to make sure that when someone does it, it doesn't crash and burn, explode, or kill something. So you want to put those sanity checks in. They may be invalid paths, but you want to test or at least know what the system does in this behavior. And then you can, of course, find valid bugs through valid paths by completely randomly walking your state model. So that's obviously a more sane usage of it. OK, so here's another weird-looking diagram. This is kind of how we look at our infrastructure. It's not a flowchart or a state diagram or anything. It's just how we see it. Right in the middle, you see Muvee, which is basically our central system for storing all the automatically generated data that we have, data that people create using this automatically generated data. It's an infrastructure that stores and makes it accessible to other people. So the typical workflow is you check in some code. At the same time, configurations and stubs are generated, and it gets stored into the system. Once everything is built and ready, you run the regression tests based on unit tests that the developer who created this module said, OK, I need to make sure this works. So these are run automatically. Once these are run, you take them out, and you create functional tests out of things which are very elemental and basic. And they, again, run through the same system. At the same time, you could have random walks or some exploratory testing that's going on. And this could, again, result in more bugs. But they're all going back, as you can see, in the same kind of, it's the same data flow. So everyone can reuse what the other did. That's the key here. So on the right side, you may have someone who's like qualifying a certain module functionally. The same language, again, goes back to the developer. You just pass the same data, and they can break it down into unit-level tests or expand unit-level tests, which go back to the functional testing that you want to do. All right, so demo. Again, through a virtual machine. OK, so we're pretty much a C++ shop. I hope this doesn't scare most of you. I couldn't help it. But you really don't need to know much about this. It's just a whole bunch of goobly-ga. But it's our interface. It's the interface definition language that we use. It basically tells me, this is my interface that I'm exposing to anyone who uses this piece of code. And these are the functions or interfaces that will be available to them. If you go deeper, you obviously get things like which classes it implements, which functions are available, what parameters are there. But the key thing here is that, of course, it's syntactical. So if you can write it according to syntax, you can parse it according to syntax. That's the basic point here. So if I take any one of these very unit-level function calls, they translate according to the system into this stub. main things here are these two functions. It has a can execute and an execute. Again, the implementation of this is more specific to your language or to how you want to, how much data you want to pass in, but the basic idea is that you just see two interfaces, no matter how complex or simple your stub is. Inside this execute function, you can do, again, whatever you want. And this is the template that I mentioned, that the template for the input for these tests is also generated automatically, because of course, if I know what's going in, I can churn it out. So we chose XML just because it seems to work for us, but you can do it in whatever way. And then when you have these templates, you can go and basically create actual unit level tests here. If I go back to my interface definition, I have this struct up here, which tells me what kind of init values I can take in. So this is documented stuff, it's there. I can just automatically create all these 4, 0, 1, 0, 2, 0f values. So these are automatically the only inputs that I expect. I'll create unit tests for it. So I have these configurations which just have these values. Pretty straightforward. Right, so then what do you do with all this stuff? So I've got a simple way of running these tests, which I'm going to show you. Of course, you can run it in whichever way you want. You can have simple apps that lump together all this data that you churned out, compile them in. If you don't need to compile it in, you don't need to compile it in. Good for you. We have C++, so we have to compile it in. But basically, from there, all these blocks are available. What you want to do is create paths. So here's a simple unit regression path. It's my init call, and these are the 4 parameters that I expected. And I'm just linking a stub with a configuration. And I'm running it through. Of course, if you put some comments, it's useful because the other guy is going to use it, knows what these unit tests are for. And then if I run it, again, I'm sure this means absolutely nothing to you, but it's basically doing a bunch of pass-fails on simple unit-level tests. The fun thing is that it ran this way for a unit test. You take the same unit tests and you create a more functional test out of it. In my case, I'm taking the init calls and then going one step further and doing something which I expect the init call to let me do, or not let me do in that case. So if I call the init with a certain mode, I expect it to block some things. If I call the init in a certain way, I expect it to allow some things. So I just reused what the developer had written for his unit testing, and I'm creating a more functional test out of it, which is a behavior which will be exposed in the application. So the good thing here is that you run it through the same way. And again, means nothing to you, but it's showing me that I can use these basic tests, calling the init, doing a function here, which actually should fail, so I'm testing for failure here. Then I do it with another value, and then I test for pass and fail, so it's both positive and negative testing in the same way. And then just so that you guys don't think I'm just printing out some text, which means absolutely nothing, I'm going to do something similar to what I did in the actual application demo I did earlier. So I'm going to create, we call them Muvees, music videos. It's a cool little term. So I'm going to create a Muvee out of the same infrastructure. Right. So here's some more goobliga. And, okay, my test's passed, but I go back to the problem. How does my video look? Did it work? Was it artistically crap? What happened? So now there's 2 things here. I do have the raw video output now, so I could, again, look at it like a manual tester and qualify it. Great. But at the same time, since I've gone a bit deeper, I've also thrown out some data that can be parsed, not raw video in this case. Basically, some data structures which I used to create that raw video, I had access to them, so I dumped them in XML form. So you can, in my case, I could actually parse that data and see, like, heuristically, did it work out? Was it good? And it's easier to parse than more complex data sets that you may output in your application. So you have the ability to churn out some helpers to test or verify what you had. Again, to prove that I'm not just doing stuff here. So it churned out an XML file, which ends up giving you the same thing again.
To listen to me whine about
So with the same method, I'm basically achieving two goals. I have the ability to go and look at what I got, manually verify it, and at the same time try and make my life easier by heuristically checking what I got at a unit level to sort of tell me whether my final, more complex data set was closer to okay or not. I could check very simple things and make sure that, oh, actually this is probably really bad. I don't even need to go look at it. So it just, making your life a little easier. Okay. So did you guys think I was bluffing? All right, so that kind of wraps up the demo. Basically, you saw there how you take the the workflow from checking in some code and automatically generating some stubs, taking those stubs, creating regression tests, more functional tests, and then, well, I didn't show you how to catch a bug because I couldn't. And right, so that's that for the demo. I'm going to quickly wrap up here with the outcome of what we think we have at this point in time. It is much faster and cheaper for us compared to other automation techniques we've used because the actual generation of the test data is automatic for us. So that saves us on a lot of time. When we have a small team, so forcing everyone to follow the same convention, write their unit tests at different levels of implementation can be a bit hard, and then making use of it is even worse. So maybe they will come up with all those unit tests, but who's going to use them? So at least this creates a way to use them a bit faster. The abstractions that are used here are more make it pretty useful too, because as I said, more complex output can be verified using more using the granular tests that they leverage on underneath. So a more functional test contains simpler tests, and I know how to verify those simpler tests. I don't know how to verify this big bad tests. And the best part is that it lets you test early. So the demo that I gave you, it's actually testing on something that's D. It's barely D1 right now. So it actually let us test that right now. It doesn't have a UI that's very stable. So otherwise, we wouldn't be able to actually find any unexposed spots in there. Yeah, I think it is more comprehensive than what we had before because I can concurrently test the different layers of my architecture that are being used in an application. So in one go, I can actually qualify a little deeper than I could go before. So that automatically gives me a bit more confidence that, okay, I tested up from up here, but I do know that things are looking good down there too, not just because the UI told me it was okay. The reduction in the need for debugging each bug, now that's a funny one because the interface you saw that I demoed with, it kind of dumps out a lot of information. You didn't see a bug fail, but actually if something had failed, assertions or error messages would have been dumped in the same area, and it shows you what path you're taking in your test, so you can tell where this bug actually, or where this bug happened and what caused it to happen and what caused that to happen. So it's a logical workflow, not just useful for the tester, but also the person debugging it. Yeah, and the great part is that we can share them. We've actually been logging bug reports using just these the INI files that I showed you. So I just said, okay, I ran this, it failed. Run it on your side, you'll see where it fails. I don't need to tell you anything else. A lot of the times, complex information is not communicated well over bug reports, and you get a developer coming to your desk and you show me how to do this. I can't replicate this problem, or my environment won't let me replicate this problem, or so on. So the sharing part is really, really helpful for us because we want everyone to test, but with different perspectives, and then reuse what everyone did in different scenarios. So abrupt ending. Really?
Mics up, please. Still waiting? Okay. When the check-in happened, you showed the model where the code gets checked in and then the stub is generated. I wasn't sure, were the unit tests actually completely automatically generated?
Yes.
Okay. Okay, and so
I'll correct myself there. The unit test wasn't completely automatically generated. The stub for the unit test was automatically generated. So of course, the inputs, some of them are there, but you can't get all the various inputs ready for that test. But the test stub is created so that you can run it. But if you already have configurations for that test, or some are automatically generated, you can run those automatically, yeah.
So what is there? So then the developer intervention after that, how does that kind of compare to what's being generated, and like how is one being useful, and where has like the automation not been enough?
Well, I mean, the automation on its own gives us unit level tests, right? I can't necessarily use all of them on a unit level. Sometimes functionality needs to be grouped together to make sense. So that's where the developer intervention, or someone comes in and basically carves out a complex stub that contains simpler things, but the data flow actually has to make sense for us to even be able to test it. I mean, that case comes along every now and then, and you can't just test them in a vacuum, or just execute a simple test and say that, okay, it was fine. I need to see it in a certain context to make sure that it works with that context.
Thanks.
Hey, I've got a question. Like for our application, it's most of the time something like you do some setting here, and then you expect something there. So you're actually setting something, and then you're verifying it worked out like that. With putting together like different tests or different settings randomly, as you do, I see like I don't know how I should be able to do that.
Let me just understand your question. You're saying that your inputs appear at a certain point in your application, and the outputs are a bit disjunct and may come at a later stage?
Yeah, it's like in general, for example, I set the color for something, and then, I mean, if my tests do have assertions in them, and the assertions are not, the things I do have like impact on other sides as well. So for example, I set the screen background color to green. Yeah, this will not only apply to one window or the dialog I'm in right now, but it has like effect throughout the entire application.
Right. So I guess what you're looking at is that you do have to, in that case, you do need some kind of pre-existing model to be able to figure out that changes here or test passes or failures here should affect test passes or failure elsewhere.
Yeah, it's like in general my assertions which I take somewhere, then like in step A I set something, and in step 35 I have an assertion which does work like if I run this test alone. But when I ran this other stuff before, or for example, something like user management or authorization. So somewhere here I said this user has no access to the entire database or something like this. And later on, by randomly putting together the tests, I have a test which wants to run something against a database. It will always fail because somewhere before I said no access.
Right, so then you're testing negatively, right? You're just checking like if your initial condition was not passed, and then you want to make sure everything that subsequently comes is going to negatively pass.
Yeah, it's like putting together the test in a random way, and then somehow these things happen, yeah.
It goes back to how you structure your model, I think. The way we do it is that we make some entry points explicit. So this has to be done, and this has to be done in the middle, go nuts, and then that has to be done. So you have to mark out certain areas in your model that this is what happens, and in between there's some gray area. So one example I can give you is, I need to initialize my engine, and then I can go nuts with media additions. I can go add pictures, video, the whole shebang. But later I'm going to put another marker that, whatever happened before me, my initialization should have passed, and I should have some media in my engine. And then if someone wants to make a movie or a video, then it should be okay. Else it should fail. So basically just marking out some parts of your, some paths in your model and letting others roam a bit more freely.
Okay.
For the modeling that you're doing, is it based on a particular standard or inspired by one, or is it all just homegrown at the moment?
It's basically a map from the state machine. So it is the XML representation is just, it's homegrown.
Okay, so it's just like message sequence charts combined with your own XML structure.
Yes.
Okay, great, thanks.
We chose XML just because we're trying to have some kind of standard, file format. So that's why we just use it across the board. It's not necessarily the best way to do it or the only way to do it. It's just what we do.
Over here. That question might have been the same as mine, but I was getting the microphone, so I didn't hear it. But for the functional tests, it looked like you were logging out XML that you could do heuristics on, as well as the multimedia.
Yeah.
I was just curious, what specifically are you dumping out there to give you enough validation that the right multimedia was written out?
Okay, now that's something that you can't probably reuse, because it's more like our proprietary, it's a representation of a video. It's actually, I don't know, you might know about this because I hear you know about DirectX. So in that case, it's a DirectX implementation of a timeline. So we're just dumping the timeline. And then we've got other code going through a timeline to find out, this is what I intended, this is what I got. So those are customized things that you have to do for yourself, depending on what kind of technology you're using.
Right, so it's actually DirectX calls.
Yes, timeline, yeah.
Other questions?
All right, I think that's it for questions. Thank you, Ali.
Thank you very much.